So my name's Taylor Smith. I'm a data scientist at State Farm. Like Desmond said, I started at AT&T. So my background is vehicular telematics and text analytics. That's most of what I work at State Farm. And so what I'm going to share today is about Scikit-Util, which is a package that originally began as just kind of a pre-processing wrapper and something we were using off the radar at State Farm, something that I developed internally or on my own time and then started using internally, and now we've got a broader base of use within the company. And I'm really excited to share it with you guys. I actually just found out from Tom, the VP of Engineering here, that they just linked it on the H2O docs. So if you're interested as we follow along, there's a link there. It's out on GitHub. So we'll go through the problem statement, kind of an overview of the project itself, and then I'd like to share side by side of what H2O looks like in general, just some of the Python API, and then some of the Scikit-Util and how this stacks up with Scikit-Learn. So, and then we'll do some time for questions. And so a bit more about me. Let's see, I've been doing data science for about 3 years at this point. I've been writing software for 6 years or so. I began writing software in C++ and then moved to Java, C#, and so my life has gotten progressively easier as I moved into R and then Python. And then I've moved into more of an applied data science role since then. And in that area, again, I'm working in the vehicular telematics. And so this is kind of what I work on is mostly how do we charge you based on how you drive in your vehicle. So it's kind of the all-state model, right? So what I want to discuss then, this problem statement, is the purpose for the wrapper that is Scikit-Util. And when I look at the analytics cycle, and this is something I think a lot of you have probably seen before, you can divide the data scientist and the data engineer role into these segmented pieces, right? So the data scientist is going to frame your problem, or a lot of times it might even be the business partner who does that for you, and then they'll gather raw data, and then they'll do the analysis, whatever that looks like. And the data engineer, there's some overlap there, right? Because they're going to help you gather that raw data, consolidate the data, and then move to production. But there's, like Shri mentioned earlier, there's this dichotomy between data engineers and data scientists, and there's this lack of communication or almost this gap. So, where's the disconnect? And when I look at that, a lot of the disconnect for me is the technology. So a lot of data scientists are going to be using more R, Python, and not necessarily as many deployable technologies, which is what the data engineers are working in. So they're working in Hadoop and Spark. And especially as this data grows at such scale, there's, at least at State Farm, and I've seen the same at AT&T, you end up building a model in one technology, and then your pipeline, be that pre-processing data ingestion, ends up getting translated into something else. And that's not a sustainable model. Something that might take you a month to build might take you 8 months to implement, and that's not, you quickly lose the value add that machine learning is bringing, right? So there's this discrepancy in tooling, and the idea here is how can we close that gap? So this moves into the motivation for the package. So like I said before, the package began kind of as an integration of these different pre-processing pipelines that come from R, come from Python, whatever. And as I moved from R into Scikit-Learn, we're a Python shop at State Farm. There's a significant lack of preprocessors that R has. R is more statistical in nature and academic, and so you see a lot of K&N and robust imputation techniques like bagged imputers. You don't see a lot of that in Scikit-Learn. Scikit-Learn seems to come more from the engineering background. But State Farm and also Capital One are kind of unique in the sense that we're very heavily federally regulated, and so we end up using a lot of these linear parametric models, which are heavily impacted by things like skewness and how we impute our data. And so bringing that carrot perspective is really important for us because we need more than just your blasé imputation or how we scale and transform our data, right? So this became an extremely relevant piece in our modeling, especially actuarially, to be able to explain, we sacrifice some of that accuracy for our explainability, and a lot of that, maximizing that accuracy still comes down to how our data is transformed, right? So At a certain point, this evolves to include some H2O modules because our data is so huge, and especially in the telematics space, the model or the data you're training on is enormous. The features you're building on are in the thousands, especially text analytics in the tens of thousands. So being a Python shop, but also transforming to scale, this was born of the idea of how can we move from the Scikit-Learn into a more portable transition into this distributed world. Right? So the objectives of the package are this easy transition, kind of the gateway drug to H2O you could think of, and then to bridge this gap between the data scientists and data engineering, because what we found, at least at State Farm, is that data engineers and data scientists have one thing really in common in technologies, and that's Python. It's much more sustainable for us to move a model out of Python into data engineer land because it doesn't require translation. And then, to provide the same familiar interface that Scikit-Learn users are familiar with, because that, again, kind of enables that gateway effect. So just to share a bit more about the motivation itself, H2O tends to have a very complete R package. And so when I give this talk, a lot of people come up to me afterwards and they ask, why didn't you add something for R, or why didn't you build it for Spark or something? So H2O has done a really great job at building a complete R package. And for anyone who's used it, I don't think anyone would contest that. And it's only ever getting better. Right? So Python, you can see here, this is ironically something I took from an R blogger site, but and funny enough, it was made in ggplot. But this is the number of questions that are built for, or asked on Stack Overflow for Python versus R over the last few years. And you can see Python is taking off at a much more rapid pace. Being data scientists in the room, we can't delude ourselves into believing these are all data scientists asking these questions. But it's clear that there's a far broader adoption of Python, and there's that observed overlap between data engineers and data scientists. And so we can target this technology, saying that this is going to optimize our portability of models. And that's really what Scikit-Util is about, is picking up your data pipeline, your modeling pipeline, and moving that into implementation. So optimizing the data exploration, model building, and model selection, moving into implementation. And it's something that's easily supported by non-data scientists. Okay. So something that's notable here for any of those who have used Scikit-Learn, are there any exclusively R users in the room, by the way? Okay. I'll have some fun conversations after this, I'm sure. You're going to corner me, but okay. Yeah, maybe. So Scikit-Learn has this really handy tool called a pipeline. And you can read in extremely sometimes unstructured, right? This nasty data that is maybe missing a lot of values, not imputed, has a lot of scaling issues, and you can just feed it through a pipeline, which will push it through transformers. So it optimizes that portability again, where you can build this pipeline of in different transformers where you push in raw data and you get your scores out. So through transformations, through scoring, and what we've done here in Scikit-Util is we've applied this to H2O. So when you use Scikit-Learn, if you're using parallelism, it's really a naive parallelism, the job lib, if you really dug into it. What it does is it actually copies all of your data to every thread. So if you're using in jobs equals -1, which will propagate that across your entire edge node or whatever server you're doing your work on, what happens is you'll very quickly run out of thread memory, especially if you're working with anything of notable size. And for any of you data engineers or DevOps in the room, that's a headache of your own. Not one that we necessarily deal with, but the other advent of H2O here is that you're getting true parallelism, and that's not something you can say for JobLib and Scikit-Learn. So you move with this idea of this clean pipeline that's portable to this distributed computing framework, and how do we join them? And that's what Scikit-Util is allowing us to do here. So, and then the other thing that I think is really notable and super exciting about Scikit-Util is when you look at Scikit-Learn or any of these other frameworks, your grid search is not constrained to merely parameter optimization in the model. A lot of times that is, in some of the built-in R modules and in H2O's modules itself. So randomized or random forest estimator, gradient boosting estimator. All you can optimize there are the hyperparameters for the model itself and not for the preprocessors. So any of say you do a box-Cox transformation, you can't really optimize your lambda values there. If you're doing any kind of imputation, you don't know which value is going to maximize your ultimate scores. And so Scikit-Util brings a Scikit-Learn-esque interface for being able to optimize your entire pipeline. So tweak hyperparameters and your transformers all the way through your estimator, retain the best estimator, and immediately go into production with the utils we have here for implementation. So, and that's what we have here. So you have a model now. How can we deploy it? And that's really what the question is all about here, and the theme for Scikit-Util. So if you're deploying in Python, you have this entire pipeline. You can pickle it, and it plays nicely with H2O's persistence model as well. So H2O has a bit more, I guess, involved form of saving the models. So if you pickle a H2O pipeline that will internally save the H2O model, it'll save all the Python structures for easy deployment. I've done several demos of this, and out on the GitHub I have a notebook, a Jupyter notebook that'll walk through what it looks like to build your pipeline, optimize your model, and then persist it, and then load it and make predictions. So this can be done in something like 3 or 4 lines of code, depending on if you already have your model loaded into memory or if you're reading it from disk. If you're deploying from Java, you can save the H2O Pojo directly from the Scikit-Util interface, and that wraps H2O's existing Python library for downloading Pojos. And future releases, actually what we're working on here now is how can we auto-generate the main class and download a fully runnable fat jar. So when you download a Pojo now from H2O, what you're actually getting is the class for the model and the H2O gen model, which takes intermediary steps of compiling and then building your own main class. But if you have a vanilla main class, it just looks like feeding an input-output directory on your CLI, then that's something that we feel like we can automate. And so that's what we're trying to do here. Let's see. But note that when you download the Pojo at the moment, you're just getting the H2O model. You're not getting the pipeline. So that's something we're also working on. Because if at the current state, it's not very portable, but that's going to be in future releases. So here's a glance of some of the current I guess, attributes of the package itself. So we have transformers, anything from imputation to box-Cox and skewness transformers. We have feature selection techniques from univariate, like F-score selectors, all the way up to stuff like multicollinearity filters, near zero variance filters, which are things that you'll find in Caret. All of you R users will find those. Class balancers, we're implementing Smote. I'm not sure if you guys are familiar with that. And then, finally is model selection for grid search and pipelines. So our roadmap, ultimately we'd really like to make this an ecosystem for not just Scikit-Learn and H2O, but integrating other distributed machine learning platforms like Spark. We're actually working on a PySpark implementation. At some point, we might play nice with sparkling water. I've got my fellow contributor here, Charles, who's a data engineer at Cap One. And again, this automated runnable jar creation. We're using Jinja for that. So I wanted to share just a quick side-by-side of what the current state of H2O in Python looks like for those who are R users and not familiar with it, next to this, the Scikit-Learn. So on the left, you're seeing H2O code, and I recognize that that's probably extremely blurry to those out there. But you can really look at this in 3 segments, right? So we have the data loading phase, which is in green. We have the splitting, which is in yellow, and then the fit model, which is in red here. So, Scikit-Learn makes this extremely clean. And 2 lines, you're loading all your data. 1 line, you're splitting it into X, Y train tests, and then you have your pipeline here, which I'm only showing 1 for the sake of readability and concision on the screen. But you can build models that have 15 different transformers to pre-process your input data, feed into an estimator. And then the current state of the H2O API is a bit more boilerplate in nature, right? So reading in your data is, here I have it in 2 lines, but sometimes if you're going from a pandas frame or reading from HDFS, this can look a bit longer, and the split is a bit less Scikit-Learn-esque as well, right? So, and down here, what you really run into in the the modeling issue is that you can't put something into a pipeline, and so you end up with this importable set of H2O objects that if you want to move this into implementation, you have to retain each individual pickle or pojo that you save. So that's one of the things we're trying to mitigate because it's just less readable and less portable, right? So, and then, compared to Scikit-Learn versus Scikit-Util here, where now Scikit-Util is on the left, you see a very similar API where, now all of a sudden H2O is behaving like Scikit-Learn. So you can build this H2O pipeline and push data into it through transformers just as you would through Scikit-Learn, right? And again, that's very portable. You can persist that to disk, load it very easily, and generate predictions incredibly quickly. So at that point, I've been yammering for about 15 or so minutes. I want to open it up for questions. I also know we're behind, so.
We have a mic over here. Yeah. Any questions? Carrie.
Okay. Are you able to speak generically maybe about performance lifting like that?
Yeah, so everything that is computing is still happening on H2O side, right? There are some elements that are a bit kludgy in the sense that manipulating some of these, like in the transformers, manipulating the frame is a little bit different, or a little difficult than it would have been in Scikit-Learn or just using pandas. That the good news here is that you never have to pull your entire data set into memory. So true to H2O's kind of zeitgeist, I guess, everything is still in a distributed fashion. Nothing ever happens in memory beyond just some slight caching, but never hold the whole data set in memory. So it operates at the same pace as H2O would.
Other questions? Don't be shy.
Hey, so there was a slide earlier that you had about the H2O, the R user questions and the Python user questions. Have you done any analytics on this, or is it just something that you looked at, was interesting, and you brought it in?
I knew I was going to get this question. So there are a few blogs I looked at, right? There's the R blog, and then there are several other analytics blogs that kind of compare them side by side and look at this. So another one I looked at was questions on Google for Learn Python versus Learn R, right? And it's hard to segment into data scientists using it versus R users using it. But again, this was just an effort to see, what's the broader user base and which is the one that engineers are using more of, and how do they integrate better? So I don't have any specific analytics there, just what exists already.
Yeah, the reason why I was curious was it would be interesting to see how many unique users are there on each of these sets and how the rank comes up, when they're asking questions. So could tell you the quality of the questions.
Good point, right?
Thanks.
Yeah. So since Python is a general purpose language, right? Not only for data analysis, it's also for programming, creating websites. So do you think the graph here of Python users is actually a broad spectrum than what they are doing for data analysis alone? Do you think the data analysis part of that graph is almost equivalent to R, or I'm a fan of R, maybe lower than R?
I don't know about that, but I'll acknowledge, and again, that this is an imperfect look. This is a proxy for what I can come up with. What's the interest in the language itself? So for those who are interested in moving into data analysis and have the background in Python, the goal, again, is to make this kind of that gateway. When people think Python for data science and data analytics, they're thinking Scikit-Learn, typically. And so if we can marry up Scikit-Learn with H2O and other distributed technologies, then all of a sudden we've kind of made it this ecosystem where people can enter one language and then dive quickly into data science in general. So I'll acknowledge that there's an imperfection. It was just kind of to make a point, right? Like there's definitely a split. The people who are using R are statisticians, and that's almost entirely statistician. The people who are using Python, you're going to get a broader array, but that also means the people who are data engineers and have more of a background in general purpose languages are going to be able to more easily adapt to something that's implementable in Python versus R. And that's a dangerous assertion to make because there's always going to be someone in the crowd who will pick on you, right? But that's what works in our ecosystem, and I suspect is very similar in a lot of other companies.
Yeah, well, I plan to learn Python, that's for sure. But I want to be good in one of the language first and then probably move to the next. Thank you.
Say that one more time. Could I, right now?
No. I'm saying the fact that you just mentioned that Python could be used across like engineers and scientists speaks about the general purposeness of the language itself.
Right.
Instead of where R is like the specific group
Academic
of
or
people.
statistics, right? Yeah. So the goal is to cover as much of that expanse of overlap between the two roles. Right?
Hey, this is Sri. We have a question on, we started predictive modeling on clickstream data. We have a huge data, probably 1 million a day, and we want to kind of sample it, everything, do the transformations, everything in Python. For these kind of large data sets, what kind of libraries do you have in H2O?
So I'll answer this with an asterisk. I don't work for H2O. This is just something that integrated the product. But anything that's available in H2O is available within Scikit-Util. So if you want to do any kind of unsupervised clustering, that's available through this interface. If you want to do any kind of predictions in a supervised sense, like random forest or deep learning, that's also available via this interface. So this merely wraps and adds to the existing H2O Python library that you'll see. So I can't say that I'm adding anything specific that's going to change H2O's behavior. What I can say is I'm altering the portability and the data pipelines and then a lot of the transformers you'll see. So I'm not adding any new H2O estimators, if that's what you're asking.
One last question. I know that we have a lot of good questions, but we're running out of time. Taylor will stay over. Maybe two. I think that gentleman has been raising his hand for a long time. Please keep it short.
In terms of functionality, when you compare Scikit-Learn with Scikit-Util, how does that compare?
Okay, so again, you have to be comparing apples to apples. So if you're using Scikit-Learn in a distributed sense, where you're propagating data across different threads, you'll see Scikit-Util will behave much more efficiently. And the reason for that is Scikit-Learn is going to duplicate your data set to every thread. And so there's a lot of I/O overhead there, whereas H2O is already storing your entire frame across distributed nodes and using a distributed key value pair to look up a chunk. So when you operate in a distributed fashion on H2O, you're not actually duplicating data. The data is already there, held distributed, and so it's going to operate much faster. But if you're using Scikit-Learn in a single thread, you might see a slight performance boost there. But oftentimes, if you're using H2O, it's because your data is too large to be held in memory anyways, right?
And on the terms of algorithms, the functionality, what you can do with Scikit-Learn, all the APIs, all the functionality.
Yeah, it's growing, and I'll say it's getting better. So most or all of the Scikit-Learn feature transformers or feature selectors that you're familiar with are going to be available in Scikit-Util. We're working on building out the transformer section, so the pre-processing transformers. And this is something that's been a bit more difficult because I mentioned before, it's harder to manipulate the data as it's distributed in an H2O frame, but it's something that we've been getting better at. So the feature selection module is relatively robust and is growing all the time. The transformer and the pre-processing section is growing as well. What you won't see as much of, and again, this goes back to me not implementing the H2O estimators themselves, but leveraging them, is, Scikit-Learn has a relatively complete set of more obscure algorithms for estimators, right? So you'll find affinity propagation and spectral clustering. That's not something you're going to find in H2O, but what we're striving to introduce is all of the pre-processing and the pipeline infrastructure that you see in Scikit-Learn that you won't find outside of that.